All right, y'all. So 2.1 deals with graphs of equations. And y'all remember there's two types of things in math. You got equations, you got expressions. Equations have equal signs in them, expressions don't, okay? All right, y'all, so let's see what this first example they want us to graph. And this is going to be a straight line. But we got y equals 3 halves x minus 2. Now, in the past, y'all might have learned about 3 different ways you can graph this. But for college algebra, since all of our lines ain't going to be straight like this one, I usually make me a little table and pick values. Now, in MATLAB, when you this is basically the y equals mx plus b form of a line. But in MATLAB, when I graph this, I'm going to pick what we call the 2-point line tool. Okay, because we got to tell it what tool we're using when we graph in MATLAB. Now, that has 2 points on it, so I need at least 2 numbers here for my x's, and then we'll plug them in and get the y values. Now, y'all, I don't know about y'all, but the easiest number that you can put in here for an x every single time is probably going to be a 0. Even if I got a fraction here, what's 0 times 3 halves going to give me? That's still going to give me a big 0, right? So let's put in a 0 and see what we get. So remember, when you make a table, you pick x values, you plug them in, and you find your y value. Well, 3 halves times 0 would give me a 0 minus my 2. And then what? 0 minus 2 gives us a negative 2. So when x is 0, y is negative 2. All right? Now, I need another number to use. Now, if there was not a fraction there, I'd probably pick a 1. But it does have a fraction. So what I'm going to do, I'm going to pick 2, since that denominator is a 2, okay? So y'all, let me show you why I'm picking a 2. That's going to give me 3 halves times 2, and then minus my 2. Well, if y'all ever done something with this stuff, you got a 2 on top, you got a 2 on the bottom. They cancel out, making a 1, basically. So if you can get rid of the fraction, then I got 3 times 1, which is 3, minus my 2. And y'all, 3 minus 2 gives me a 1. All right, y'all, any questions so far? So, table, you pick the x's, you plug them in, you get the y values, okay? Now, let's go graph this. So I'm going to graph these in on my pad here. And my numbers are fairly small, so I'm just going to number this out about 5. All right, y'all, the x's and the y here. We treat each one of these like an ordered pair. So the first ordered pair would be 0, negative 2. And then my second ordered pair would be 2, 1. So remember, these are in the form of your x and your y. The x's are going to go left or right. The y's will go up or down. X's left if they're negative, right if they're positive. The Y up if they're positive, down if they're negative. So negative left, positive right on the X. Up is positive, down is negative on the Y. So y'all, we got first point 0, 2. Well, 0 for the X's is right in the middle here in what we call the origin. So 0 for the X puts me there, and then that Y value was negative 2. So from there, I'm just going to go down 2, and I got my first point. Then I got 2, 1. So starting with the X again, starting in the origin. 2 wants me to go right 2 since it's positive. The 1 wants me to go up 1 since it's positive. Now, I will say this, in MathLab, when you're graphing it, it has a little yellow banner there, and you can watch your point as you're moving the cursor around, okay? All right, y'all, but at that point, I got my 2 points, so my line's just going to come up through there. And now I'm going to show us this on MathLab. So y'all, let me get to my assignments here.
Excuse me. At the beginning of the lecture, you pointed out the differences between graphs and I think equations. You said one of them had numbers. Can you repeat that for me?
So what I was saying on that, we're doing graphs of equations, and I was just reminding y'all that equations had equal signs in them.
Okay.
Now, if you see something that we're working and it don't have equal signs in them, those are just going to be what we call expressions.
Okay.
And all we can do to those is sort of simplify them, okay? But you'll start seeing those expressions pop up probably next week.
Okay.
Now, y'all, they don't have, well, they changed it up a little bit, but I'm just going to show you how to graph the one I just did. So I click this box that says click to enlarge graph. Now, remember, we said we need to use the 2-point line tool, which is in the middle top row. Click that. And then I'm going to plot my point 0, negative 2. Now look in the yellow. You see right now I'm at 0, 0. Once I pull down, I'm at 0, negative 2. I'm going to click that. Y'all, the second point was 2, 1. So starting in the middle, I'm going to go right 2. And then I'll go up 1. So I need to be at what? 2, 1 right there. Once you plot that second point, it draws the line for us. And we can move on with it, okay? So then you'll click save. It'll put the picture there. And then we'll go to the next question. Now y'all watch this. I'm going to pull up the calculator for this one just for a second. Now watch this on my TI-84. I can hit this button on the top left that says Y equals. That's the graph and stuff, this top row of buttons. So hit Y equals. We're going to put in our equation. 3/2 would be 3 divided by 2. Now I use this X in the middle that has link above it. I click that button and it'll put the X up for me. And then I had minus 2. Y'all, that is one way you can put this in. Let me show you the other way. If you want the 3/2 to look like a fraction, you can hit the green alpha button and the Y equals button. Number 1, ND, that's numerator over denominator. So if I hit enter, I can then put my 3 on top, arrow down, put in my 2, and then arrow right and put in my X minus 2. So either way, 3 divided by 2, then the X, or you can make it look like the actual fraction. Now, before I graph it, I'm going to show you the table that you can use to plot from. So you see the graph button above it, it says table in blue. If I hit the blue second button and then the graph button, it'll pull up my table. So let me see. My first point I used was 0. And y'all look at that. There's 0, -2. That was a point I picked. And I picked 2 for an x. Well, at 2, we got a 1 just like we had. So you see, I didn't use a 1 because I would have had to graph a fraction there, right? And then y'all, if you arrow up, you can go to the negative number side, okay? So if you don't want to set up a table, get good at graphing, and then you use this table to help you graph it from. Now, if I want to see the graph, guess what I'm going to hit? The button that says graph. And y'all, there's our little graph going straight up hill to the right like we had, okay? So let me see something over here. All right, so I guess it does doing that. All right, y'all, so back to the notepad. So question on that one. All right, I'm not gonna lie, straight line graphs aren't bad unless they give them to you in a different form where they're not solved for. So let me just turn this one over and move my camera back up. So this one says graph 4y plus 2x equals 2. So, y'all, sadly on this one, no matter what, you have to solve it for the y. Now, we do know it's going to be a straight line graph because that x does not have any exponents on it, okay? So since my x don't have any exponents other than a 1, remember, if there's not an exponent there, we treat it like a 1. So that's going to make this a linear again. And it's going to be another one of them 2-point line tools, okay? So y'all, to solve this, I need to get this 4y by itself over here. So what would you do to the 2x to move it over here?
Subtract.
Okay, so let's subtract that 2x. So y'all, this side, the 4y comes down. That stuff cancels on the left side. Now, what gets people a lot of trouble? These are not like terms. I cannot do 2 minus 2 on this one. They're not like terms. So what I'm going to do is sort of put it into order the one had while go on number 1. Remember, they had the x's and then the number. So I'm just going to bring my negative 2x to the front. And since this 2 is positive, we'll do a plus 2. Now, you could do 2 minus 2x. That won't hurt nothing. Okay? The thing you can't do is actually add them together, okay? So then what would we do to make this a 1y?
Divide it by 4.
Divide by 4. And y'all remember, multiplication and division goes to everything, right? So everybody's going to get divided by that 4. Now it's just a matter of simplifying all my fractions. So this one, 4 divided by 4, will give me a 1y like we wanted. Oh, y'all, can't divide that, but can you reduce those two fractions? I know that'll be a negative what?
1/2.
So negative 1/2 x. And I guess that's going to be plus a 1/2 at the end. Alrighty, y'all. So on this one, you can make another XY table. But what I'm gonna try to do is get y'all good on this calculator. Oh, let me let one in. And also, I'm gonna go to Y equals, clear that out. And I'm gonna use the fractions for both of these. So I'm gonna hit alpha Y equals ND, enter. So we had a -1/2, so -1 on top, 2 on the bottom, arrow right, put in your X. And then we had +1/2, so I'm gonna hit plus, and then I'm gonna hit the alpha Y equals again, and hit enter for the fraction, and then put in my 1/2. And arrow out, okay? All right, so I want to see that table, and let's find 2 nice points we can plot for this, okay? So second graph will get my table. All right, y'all, I got a few I would pick. I'd probably pick -3, 2, -1, 1, 1, 0. So I think for me, I'm going to do -1, 1. And then how about the 1, 0? So y'all, I'm doing the one I got highlighted, and then that -1, 1. That way, if you don't want to plot fractions, you use this table and you find numbers that are not fractions, okay? All right, so y'all, I would then go back to my math lab.
Wait, I'm sorry. I have a quick question.
Yeah.
How did you make the negative number? I missed that part. What button did you
So
push?
let me go back to my share. So you're talking about the -1/2 here?
Yes.
All right, so you don't want to use subtraction for that. See, if you use
Okay.
subtraction, it'll freak out the calculator. But look on the very bottom by the enter button. You see this little negative down here in parentheses?
Yes.
Uh-huh,
Oh, okay.
click that one, and then come in here and make your fraction up. So let me hit enter. What do we have? 1/2. So 1 on top, arrow down, put in my 2. Then my arrow right and put in my X. And then what was it? +1/2. So plus, and then alpha Y equals again from a fraction. And then that was a 1/2.
Okay.
So we got it all in now. If we want to see the line, what it's going to look like, we're going to hit enter. And it's a downhill line going to the right, okay? So y'all on that one, you would graph it just like I did the one while ago. You would come in, plot 1 point after you pick that 2-point line tool. It's going to give me a different number, but let me pull it up anyway just to graph it. Yeah, so they use 6s and 3s. But what's wild was that 3/6 would give them the same answer mine got, wouldn't it? We had 2 divided by 4. Well, they're going to have 3 divided by 6, other than the 6 at the end. But okay, we just want to see how to graph it. So we're going to go to our 2-point line tool. -1, 1. So starting in the middle, I go left to -1 and up to 1. Click that. And then we had 1, 0. So starting in the center, I'm going to go right. Now, y'all look, each time you click it, it's going by halves. So I need to click it all the way over to my 1, 0 and hit enter. Y'all, there's a line going downhill to the right. So you would save that, check it, and be done, okay? All right, y'all, look what's coming up. Y equals a negative x squared. So y equals a negative x squared. All right, so let's get back to our pad. These x squared tool graphs right now, they call them the x squared tool. And let me go back to it and I'll show you which one it is. So if you click the enlarge graph, you see the second row, the first one, it has 3 dots. It calls it a 3-point quadratic tool. That's the one we're going to use for these graphs. So x squared graphs, we use a 3-point quadratic tool. And really, the only way to graph these by hand is to set up a table and use 3 x's, because you got 3 points we need, and then we'll find the 3 y values. Now, y'all, in this chapter, if I get a graph with an x squared like this, my 3 numbers are going to be -1, 0, and 1. Now, here's something I want you to realize on an x squared graph. In this section, whatever answer I get at -1 will be the same answer I get at a +1. Because -1 squared is the same thing as a +1 squared. But y'all, what messes people up is that little extra negative here. So let me plug in a -1 first. Now y'all realize we're about to put a -1 in for the x, right? But guess what? There's already a negative in the front. So we got to keep this negative. Anytime I put a negative number in, I'm putting it in parentheses and then squaring it. So I got my -x squared, okay? Now, y'all remember this thing called PEMDAS? Order of operations says start with parentheses. Well, I can't do nothing inside the parentheses, so that means the exponent is next. This exponent of 2 only affects that -1. So my first step, I'm going to bring this negative down. So y'all, what is a -1 squared equal? Right, -1 times -1 is
+1.
+1. But y'all, since there was a negative in front, it actually keeps my answer negative. Now, the biggest mistake I get on this is people see these 2 negatives and they want to make that a plus. Well, you can do that if it wasn't for that exponent, okay? When you got exponents involved, this is really 3 negatives getting multiplied, right? That's like a negative times a -1 times a -1. Does that make sense? Because that's what that exponent's telling me, right? Well, a negative times a negative times a negative is a negative. All right, y'all, what are you going to get when you put a 0 in for that x? Well, 0 squared is a big 0, and 0 times a negative is a big 0. So then we're going to put this 1 in. So bring down the negative, put in your 1 for the x, and square it. So remember, the exponent only affects the 1, so this negative on the outside has to come down. And y'all, 1 times 1 is 1. Okay? Now, did y'all notice? I got the same answer from -1 and 1. These graphs are symmetric. So if you use a -2 and a 2, those answers will be the same, okay? All right, so we can do this one on the calculator. So let's share that. I'm gonna clear out my history over here. All right, so remember, negative x squared, I gotta use the negative on bottom in the parentheses. I'm gonna put in my x. And then right here on the left side, to the left of the 7 and up, is an x squared button. If you hit that, it'll square that x for you. So there is our negative x squared. Look at this table. I want y'all to see the symmetry. So I'm going to hit second graph to go to the table. And y'all look at that. -3 gave me -9 for the answer. +3 gave me -9. 2 gave me -4. -2 gave me -4. They are very symmetric, okay? And then here's the numbers I used: -1, 0, and 1. So let's hit graph and see what it's going to look like before we mess with Math Lab. Y'all, there it is, the upside down parabola, okay? So we want to go graph this in Math Lab. All right, so here we are, -x squared. Oh, it gave me the exact same problem this time, so we're good to go. I'm going to click to enlarge graph. Remember, we want this 3-point quadratic tool, so click that. And then it don't matter what order you go on this one, okay? So I'm going to go to -1, 1. Whoops, -1, -1, right? 0, 0. And then I had +1, -1. Y'all watch that little banner when I'm doing them because this Math Lab is so picky. If you just get a little bit off, it throws that point out of line, okay? All right, so we got a 3 points. You just save it and then check your answer. Y'all, this is pretty much the same thing. Y equals x squared plus 3. So it's still got this x squared term in here. So this is still going to be our 3-point quadratic. The exponent that's the largest for your function is always going to determine the shape of these graphs, okay? So the x squared was the u up here. This x squared is going to be a u-shaped parabola too. Now, since it's an x squared graph, I would use the same 3 numbers: -1, 0, and 1. Every x squared graph in this section, I'd probably use those 3 numbers, okay? So let me get them set up with my 3 numbers. And remember, whatever I get for -1, I'll get the same answer when I put the 1 in, okay? All right, y'all, well, -1 times -1 gives me 1 plus 3, and 1 plus 3 is going to give us a 4. So I pretty much know that this 1 right here is going to give me a 4, okay? All right, here I got 0 squared plus 3, so 0 times 0 is 0 plus 3, and that'll give us a 3. All right, y'all, 1 times 1 is 1 plus 3. And let's see, 1 plus 3 will give us 4. So y'all, if you're working these x squared graphs and you're using numbers that are like -1 and 1, if these don't match up, one of those 2 you did wrong, okay? All right, so we'll see how to do it on the calculator real quick, and then we'll go to next one. All right, y'all, so I had an x squared, so I'm gonna hit the x, come down here and square it with the x squared button. And then I had plus 3. Now, y'all, do y'all know there's another way to do exponents on here? Let me clear this. Y'all see this little upside down V looking thing under the clear button? We call that a caret. So I could do the X and then hit that upside down V. You see how it kicks my cursor up? And then I can put my 2. But y'all, here's the thing. If you use that, you see how the cursor's still up there with the exponents? So you got to arrow right to bring it back down. And then put in your plus 3, okay? But y'all, either way. All right, our table. So here's the numbers we use. -1, 4, 0, 3, 1, 4. But y'all, any numbers you can use on this would work. Now, let's look at this graph. We know it's going to be U-shaped. So it's sort of U-shaped, and it's a little bit above that x-axis, it looks like. So for Math Lab, I want to click to enlarge graph. I'm going to choose my 3-point quadratic tool. And then I'm just going to plot them numbers. I had -1, 4. What we have next? 0, 3. So starting at 0, go up 3. And then we had right 1, up 4. Okay, y'all, then you what? Save that and check your answer. So it's not too bad once you get the hang of the Math Lab, okay? Oh, what is this stuff, y'all? What's them bars mean?
Absolute value.
Absolute value. There you go. So we're doing the absolute value of x plus 4. Now I'm going to say this. Of all the graphs you do today, this is the picky graph. Now, absolute value is going to make a V-shaped graph. And it has 2 points. So it's a 2-point absolute value. But y'all, what makes it picky is no matter what, we got to get the first point to be the little V point right here. The second point can be any other point we want. But the first point has to be the V. Now, the thing about this V point is it's going to have a Y value of 0. So let's make a note of that. The first point must have a Y value of 0. And that's just because of the way Math Lab is on this question, okay? So what number can you put in for that X to make this thing equal 0?
-4.
-4. So y'all, my first X has to be a -4, okay? So if you went over here and put in -4 plus 4, you'll get absolute value of 0. And the absolute value of 0 is 0. So this one, you sort of got to get the first point by focusing on the Y value first, okay? Now, give me another number I can use, and I don't care what number y'all give me. But keep it small for me. How about that?
1.
What did you just say? 1?
Yes.
Okay. Now, put a 1 in there. Now, remember, when you work inside the absolute value, whatever you take the absolute value, that answer better be positive coming out of there, right? So let's see. We're going to put a 1 in for the X. So remember, treat Treat absolute value like parentheses. You got to do the work inside first. So 1 plus 4 is 5. So the absolute value of 5 is 5. So y'all familiar with your absolute values?
No.
Well, let me just give you all a quick refresher. Let's see what y'all know. What's the absolute value of -5?
Unmuted.
5.
What'd you just say?
5.
5. Absolute value don't care about the sign. Absolute value is looking at how far is that number from 0. Well, -5 is 5 places from 0. What about this? What's the absolute value of a +5?
-5.
5.
5. Anything inside here is going to come out positive. Because y'all remember, absolute value, if you're looking at a number line, absolute value don't care about the direction. It just wants to know how far I am from 0. So 1, 2, 3, 4, 5 units, okay? Same thing here. 1, 2, 3, 4, 5 units. Although they got different signs, they're both 5 places from 0, okay? So how about the absolute value of a -7? Oh, I heard you, Leah. Well, I lip read you. You was right. I just didn't hear you. You're muted. But it looks like you said 7.
Yes.
And y'all find the same thing with this. Absolute value of +7 is 7. So the stuff inside these absolute values got to come out positive. The only way an absolute value will be a negative is if you got a negative in front. Now, if I say what's the answer for this one, well, the absolute value of 5 is 5, but you got a negative out front, so that makes that a -5, okay? So that's the only way you can make absolute value negative is if it's negative out in the front of that thing, okay? All right, y'all, but remember, first point, when you graph in MATLAB, better be a 0 for the y value. Now, let me go to y equals and clear this. I'm going to clear my history over here. Yo, there's not an absolute value button on this calculator, is there? So watch what we got to do to get it. When we need hidden things, we're going to hit this math button here. I'm going to hit the math button. I'm going to arrow right until I highlight the NUM column. Y'all look at number 1. What's it look like? ABS. Guess what that is? Absolute value. When you hit enter on that, it puts the brackets on the screen for us. And what do we have inside? We had an X plus 4. And then I'm just going to arrow out. Okay, so remember, math, and then highlight number, and it'll be choice number 1, ABS. All right, y'all. These graphs are sort of symmetric around that vertex. So let me show you my table, second graph. Now remember, I had to use a -4. So you see how the numbers are getting smaller going up? Well, there's my -4, 0. I would search until I got my 0 for the y, because that's got to be the first point. And then y'all said my other point was 1, and there's my 1 with my 5, okay? But once you plot the -4, 0, you can plot any of these other points. So y'all remember it looks like a V, so let's hit graph. And there you go, it's a V going down that left side. And I bet that's hitting at that -4 we picked, right? All right, so how about Math Lab? Now y'all see what that graph looks like on that calculator. Take the enlarge graph. You're going to pick the 2-point absolute value tool. Now y'all don't graph this first one. I just want to show you what happens if you graph it wrong, okay? So what if I did my 1, 5 first, and then I did my -4, 0? That don't look like the graph we just drew, does it? Because we didn't start with the V point. When we started at 1, 5, we're telling it the V is up here. That's wrong. You got to get that thing in the right order. So pick the V tool, go to -4, 0 first, put that point. Then you can come over here and get the 1, 5. And y'all look at that. That looks exactly like what we had on our calculator. So we would save that and check our answer and move on. All right, so the last of the different types of graphs will be this y equals x to the third. This one is cubic, and let me show you when I pick this one. Y'all see that little squiggly line on the second row? Look at that. 4-point cubic tool. Y'all realize that means I need 4 points for this one, okay? So 4-point cubic tool. So let's go knock it out by hand to get our numbers. Now, y'all, I don't know what y'all remember about cubes, but I would keep these numbers small for a cube. Let's just play with that a little bit. What is 5 cubed equal? Well, y'all, that would be 5 times 5 times 5. So if I pick a 5, my y value will be 125. I'm not drawing a graph out to 125, okay? So we're going to keep these numbers nice and small. The biggest number I would use on here would be a 2, but I need 4 of them. So I'm going to do a -1, 0, 1, and 2. Y'all, even if I picked a 3, what's 3 times 3 times 3? That's 27. That's bigger than I want to graph. Okay? On a cube, keep them numbers small. And we would come in and do -1 to the third. We would come in and do 0 to the third. We would come in and do 1 to the third. And then 2 to the third. All right, y'all, so here we go. -1 times -1 times -1. You got 3 negatives, so that's going to stay negative. And then 1 times 1 times 1 is 1. So I get a -1. So when you got a cube, if there's a sign in front of the number, it's going to stay negative, okay? All these are going to stay positive. All right, y'all. 0 times 0 times 0 is a big 0. All right. 1 times 1 times 1 is a 1. So, y'all, what is 2 cubed going to give us?
8.
8. There you go. So 8's the biggest number I got to worry about on this one, okay? Now, I could have used a -2, and that would have gave me a -8. But like I said, them 3s and -3s are going to put you up in 27 range, okay? So that's probably bigger than we care to graph. Now, can we do this on the calculator? Of course. Go to y equals. Let's clear this stuff out. So we had x to the third, so I'm going to hit my x. So now, since I got a cube, I'm just going to use this, what I call caret key, the upside down V under the clear button, and put in my cube. Now y'all look at this table here, second graph. So look, if you'd have used a -4, your graph would have been out to -64, -3, -27, 2, 8. So that's the biggest we had. 3 would have been 27, 4, 64, 5, 125. If you'd have picked a 6, your graph would have been out to 216. Y'all, that's too big for a piece of white paper, okay? Now, watch this graph when I hit graph. It's that little squiggly line that comes up on the left. It sort of crosses over the middle and then goes uphill, okay? So we're about to do that in MathLab. So let's go get MathLab. I'm going to click the 4-point cubic tool. So my first point was -1, -1. I had 0, 0. This one's tricky because them points are so close. I had a 1, 1. And then my last point, watch, it looks like a straight line, but watch this. 2, 8. When you put that last point in, it makes your little curvy line for you, okay? So then you just hit save on that and check your answers. Y'all, this was just like the other two quadratic ones we done. The x squared minus 5. So if I was to do it by hand, since it's a quadratic, I would pick probably a -1, 0, 1. But y'all, in this section, it don't matter. If you like to do positive numbers, do a 0, 1, 2. So let's see what we get for these y values. So I got 0 squared minus 5. I'm going to have 1 squared minus 5. And then I'll have a 2 squared minus 5. Well, 0 squared is a big 0. And 0 minus 5 is going to give us a -5. Now, these won't be symmetric like I had earlier because I didn't use a -1, 0, 1, okay? So you won't see some symmetry, although the graph is symmetric. So what is 1 squared? We said that would be 1 minus 5. So y'all, what is 1 minus 5?
-4.
So -4. And y'all, looks like we're putting in, what, a 2 on this one? So 2 squared will give me a 4 minus 5.
-1.
-1. So these three numbers I can use definitely when I graph it. But remember, we can always check this first on our calculator. So go to y equals, clear this stuff out. We had an x squared, so x squared minus 5. All right, also the table, second graph. So there was my numbers. So we did what? 0, 1, 2. We got -5, -4, -1. But y'all watch, I just want to go up to show you that they are still symmetric. -3 and 3 both gave me 4. -2 and 2 both gave me -1, and so on, okay? So it will still be symmetric because it's going to look like a U-shaped parabola, okay? All right, so let's go graph that on MathLab and be done. So click to enlarge graph. I'm gonna grab my 3-point quadratic tool. So I had 0, -5. 1, -4. So see, it still looks like a straight line, but when I come in and do my 2, -1, it makes it look like a U-shaped parabola for us, okay? So then we would just save that and move on. All righty, y'all. So that was basically our college algebra lesson for today. Now, you got support 2.1, but y'all support is only going to do the straight lines, okay? I think there's like 4 or 5 straight lines that you're going to graph. And then do this 2.1 college algebra, okay? Now, what we'll do, we won't do support tonight since we ain't had homework yet. But Thursday night, if you need help on any of this graphing from today and stuff, we will knock out that class starting at as soon as this one's done Thursday, I'll get into support for anyone that's going to need extra help on this stuff, okay? So, do we got questions tonight?
No, I just got to get used to this calculator. I'm just used to putting it on graphing paper.
Yes, and you want to definitely get good use on this calculator in this class because we're going to have so many functions that require a lot of points.
I have to mess with my kids and be like, oh, I need some help. Show me how to use this calculator real quick.
Well, remember, I'm sending y'all this video out as soon as I get it uploaded into YouTube and get a link.
That's perfect.
I'll send this out, and then you'll have the whole lecture you can go through and watch me doing that calculator, okay?
Okay, thank you.
Mm-hmm. All right, y'all, so let me stop my share there. Any of y'all got any more questions?
Nope.
Thank you.
So I like to
Oh,
keep it a
thank
little
you.
mellow this first night. I'll send this video out through the announcements in Blackboard later, and that'll automatically email you to let you know that you can get into the announcements and get the link for the video, okay?
Okay.
Mm-hmm. And then we're going to do that after every one of our lectures. So let me quit this recording now.